Okay, so this is for my advanced 8th grade students. This is 10-1, lesson 10-1, and what you're doing here is learning about solving linear equations. I think that you have done that previously in other classes, but we're just going to kind of review this and do some of these activities here. So solving equations like balancing balance, basically. So whatever you do to one side, you have to do the other to make it stay balanced. So if the scale is balanced, how many cubes must be in each bag? Explain how you determine your answer. So what we're going to do is we're going to first take away what's the same, right? So if I have 3 over here, then I can take away 3 over here, and that won't change the balance of the scale. And then from there, I can redistribute for each of these bags. So one bag, so there's 2 bags here, and there's 4 of these pieces. So if I were to divide it up evenly, I could put 2 in each bag, so each bag is worth 2. So we're going to put if it's balanced, 2 pieces would be in each bag. Write an equation to represent the diagram shown below. Let x represent the number of cubes in a bag. This is the first piece this is. Okay. So if we were to write this equation, we'll just say that this is x, right? So we would put 2x plus 3 equals 7. So that would be the equation. Okay. Up here we didn't put an explanation. It says explain how you determined your answer. We're going to put here what we did. We took away 3 cubes from each side. Then divided the remaining cubes evenly among the bags. Okay, so let's go to the next page. So on 120, here it says one way to solve the problem involves removing equal amounts from both sides and then regrouping the remaining cubes, just like we did. Write an explanation for both the second and third diagrams to the right of each. Okay, so here I'm going to put here, take away 3 from each side. And then we're going to put here, divide the remaining cubes equally among the bags. Okay, so here from the diagram shown above, how many cubes are in each bag? We're going to put 2 cubes. Model each of the following problems using bags and cubes, then determine how many cubes are in a bag. Record your work using a diagram like a balanced scale. Write an equation for the original problem, an explanation for each step, and solution. Let x be the number of cubes in a bag. Okay, so that's going to be here. So it says if 3 bags are on one side of the scale, so we're going to put 3 bags. those are going to be X. On one side of the scale and 12 cubes are on the other. So we put 12 of these. How many cubes must be in each bag to maintain the balance? Well, it would just be, if I divide this equally into 3 groups, it would be 4 per bag. Okay, so we're going to put here, divide cubes evenly among 3 bags. And we're going to put X equals 4. Okay, and then this one, if 3 bags and 10 cubes are on one side, this one was, yeah, so this one has 3 bags and 10 cubes on one side. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 3 bags, 10 cubes on one side, and 16 cubes on the other. So we do 4 by 4. Okay, how many cubes must be in each bag to maintain the balance? So there's 10 here, and there are 10 here too, so we can take out 10 cubes here. We can take out, so this is 8, 9, 10, so we do this and this. So where we only have 1, 2, 3, 4, 5, 6 cubes remaining, we only have 6 cubes remaining. And I did it evenly. I have 1, 2, 3, and then 4, 5, 6. Okay, so that means that first we took away 10 cubes from each side, and then divided the cubes evenly among the bags. Okay, I'm going to put here, so X equals 2. Okay, and then let's go to the next one. So here we have example A, solve 3x plus 4 equals 7, use inverse operation, subtract 4 from both sides. So here, instead of using pictures, we're doing it just with numbers. So same thing as we were doing before. They had 4 cubes here, 7 over here, so they took away 4. And then they had 3 bags or 3 X's left with 3 cubes. And then if you just divide that evenly, you would divide by 3, which would give you 1 per bag. Okay, in the equation 3x plus 4 equals 7, x equals 1. Substitute 1 for x in the equation to verify. So you could actually prove that that's true by putting it back into the equation, right? I could put what I got for x, put it back in, and see if that actually gives me 7. And if you do that, it does. Okay, so that's an example. We're going to do that on probably the next page. So let's see what they have on the next page. So here it says solve each following solve each of the following algebraically using inverse operations. Okay, so the diagrams work really good when you have whole numbers, but not so good when you have decimals and fractions. But we can do that algebraically. So let's go ahead and try this with our inverse operations. So this would be, point 0.4 equals 18. So what I'm going to do is I'm going to subtract 0.4 because I'm always going to do my adding subtracting number first. So I'm subtracting 0.4 from both sides. And I'm going to move this here because I don't have a lot of space. So when I do that, that's going to be 2x left over on this side because these will cancel. And then I'll have 18 minus 0.4, which would give me 17.6. Then I'm going to divide all of that evenly between two x's or two bags. When I do that, I'm dividing, right, because that's the opposite of multiplying, I'm dividing. And when I do that, these will cancel, or it's just 1. It's really just 1, but I just take that out. And then 17.6 divided by 2, well, let's see, 17.6 divided by 2, that would be 2 times 9 is 18, so 2 times 8, 16, it's 1, and down to 6, and then 2 goes into 16 times 0, so this is going to be 8.8. Okay, so there's that one. I'm going to go ahead and do this fraction one as well. So on this one, same thing. If you want to get x isolated by itself, you're going to need to take away the adding subtracting number. So this is minus 4, so the opposite of subtracting 4 is to add 4 to both sides. Remember, we're keeping the balance. When I do that, these will go away. I'll get negative 1/3 x left over, equal to 12 plus 4, which is going to be 14. And then, if I have negative 1/3 bags, and I have 14 cubes, I still have to divide evenly among the bags, so I'm dividing by this number because I want to get x by itself. So the opposite of multiplying is dividing. So we're doing divide by negative 1/3. And you can put this in your calculator like that with a parentheses. Or if you remember your rules from 6th grade, if you want to divide by a fraction, you can multiply by the reciprocal. So 14 times negative 3 over 1 would also be accurate. So 14 times negative 3, that's going to be 42, negative 42. So x equals negative 42. Okay, so you should be able to do the rest of these. You can do it on another piece of paper, or you can try to squeeze it in like I did, which is not like the best, but you can do it if you need to. I'm going to go to number 6. It says construct variable arguments. How do the steps to solve an equation algebraically represent the bagged and cubed process from previous items? The bags are an unknown value. And x is also an unknown value. I'm going to have to think about this a little bit more, and I might come back to this, but for now I'm just going to put the bags are an unknown value and x is also an unknown value. Number 7, it says use properties of operations or other explanations to describe each step in solving the equation 3 times x minus 2 equals 8. So something else that you need to know is that you have to have both sides simplified completely before you can start solving. So this one is not completely simplified, so I'm going to have to distribute this first. So your first step is going to be to distribute on one side to simplify. Then you're going to have to, let's see, add, we'll use inverse operations to add 6 to both sides. Then you would have to divide by 3 on both sides. Again, using inverse operations. From there, you would use, it said, in the other one it said use multiplicative identity. To divide both sides by 1. To get answer. And I guess these two were probably up here somewhere where we probably had to rewrite in between here. Should have probably said rewrite, but I just wasn't sure. So these really are all your steps, so just don't worry about that. Okay, let's go to our next page. I think this is our last page. So it says, check your understanding. Kathleen is spending summer vacation hiking in Canada and wants to dress appropriately for the day's hike. The local news reports that the high temperature is expected to be 20 degrees Celsius. Use the formula F equals 9/5 Celsius plus 32, where C is the degrees Celsius and F is the degrees Fahrenheit, to determine the local temperature in degrees Fahrenheit. Okay. Okay, so they want us to convert 20 degrees Celsius into Fahrenheit, and they gave us the formula, so we would plug that in. So if Fahrenheit equals 9/5 C, which would be our 20, I'm going to plug in 20 for that, plus 32, and you can put this in your calculator as long as you keep this in parentheses. This would end up being 36. Plus 32. Wait, actually, sorry. Yes, that's right. Which is going to be 68 degrees Fahrenheit. So I'm going to put here 68 degrees Fahrenheit. Solve for the variable in the equation. So that here, so this is going to be negative 3x plus 11 equals 26. Again, this is an equation that we can solve algebraically. You use inverse operation, meaning if it's multiplying, you divide, if it's adding, you subtract, and you do it to both sides. So if I want to get x by itself, to move it over to the other side, I'm going to have to do the opposite, and I'm always going to start with the adding, subtracting number. So I'm going to subtract 11 from both sides. That's going to give me negative 3x on this side, because these will be just 0. And then 26 minus 11, that would give me 15. And then from there, we're just going to divide evenly. And we're going to divide by this number next to the variable, so this will be -3. So this becomes x equal to -5. Okay. So what about number 10? Number 10, you have 5/2, y equal to 10. So we want to solve for y. So don't let it throw you off if there's no adding, subtracting number here. So if you notice, there is no subtracting number or adding number here. So we're going to go straight into the dividing. So you can divide, like I said, in your calculator by the whole fraction, because that's going to be easier to remember. Or you could multiply times the reciprocal, which would be 10 times 2/5, which is going to be 4. Okay, so my y here is 4. And lastly, solve for p in the equation 0.3p plus 1.75 equals 6.25, sorry. I'm going to write that out, 0.3p plus 1.75 equals 6.25. So again, I'm going to solve this using inverse operations, Using inverse operations, the opposite of adding 1.75 would be to subtract 1.75, so I'll do that. So this will be 0, 12, 5, so this would be 4.5 equal to 0.3p, this canceled. And then the opposite of multiplying is dividing, so we're going to divide evenly both sides by 0.3. So let's try to divide this. You can put that in your calculator. I'm going to have to do it by hand. So this will be, move this over one. 3 goes into 45, 15 times, I believe. Yep. So this would be 15. Okay, so you're just going to do those practice problems, and you can work together if Ms. Pestle allows that, and just, if you have any questions, look over your examples again, and I'll help you when I get back. Alright, thanks guys.